Like to start off by thanking you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And as you can guess, today we're going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models, including the latest models incorporating new cutting-edge technologies, which are pretty cool. So we're going to get into that in a little bit here. But anyway, over the years, I would typically begin these types of presentations with a discussion of the importance of STEM education. I talk about changes in the manufacturing environment and, of course, the growing need for highly skilled workers in the modern workforce. But at this point, I really think it's pretty well established just why technology-focused education is so important, and I'm guessing that's why you're here. And so I'm going to dispense with any preamble and jump right into the discussion of what fischertechnik is, and then I'm going to show you each of the current models that are available in the simulation family. Well, essentially, fischertechnik simulation models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line itself consists of a series of pre-assembled small-scale models which are designed to replicate in both appearance and in function various automated robotic models and machines and systems that are commonly used in commercial manufacturing. Now, before we look at each of the models, I'm going to provide you with just a little bit of background on fischertechnik. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, actually almost 60 years now, all based around their unique building system. And what makes this system so unique is that, unlike a lot of the other popular construction systems that you'll encounter out there, where the components are designed stacked, fischertechnik was created with more of an engineering mindset. The core building block in the system, like the example that you see on the screen, is designed to enable attachment from all six sides. And because of this, it allows for almost limitless design possibilities. Now, many of the parts that are in the system are designed to slide together and lock in place using a tongue and groove assembly method. And because there are so many different parts available, hundreds and hundreds of different parts, they'll help technical builders to address very specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who, of course, you see on the screen. And Mr. Fischer was noted for countless innovations used in both the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. So that's pretty impressive. And prior to creating fischertechnik, Mr. Fischer was first noted as the inventor of synchronized flash photography, and that was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. I'm sure we've all used them at some point. His company, the Fischer Group, continues to employ thousands of workers around the globe, producing many variations of fastening devices used in building construction. And they also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik building sets, whether those intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology. Many of the products offered by fischertechnik for the education sector are subject-specific sets focusing on different STEM-related concepts, things like mechanics, pneumatics, robotics, renewable energy, and so forth. Many of these sets either include curriculum or they include detailed teaching and activity materials, and in most cases, students are asked to build a progression of models using the unique fischertechnik system and then perform various experiments which allow them to explore and understand key aspects of that subject. But the line of fischertechnik simulation solutions, which are, of course, are the focus of today's presentation, are something much different. The line consists not of kits, but of a series of pre-assembled small-scale models which replicate, again, in appearance and function, various automated robotic machines and systems. Some of the models in the fischertechnik simulation line will include things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models, which again focus on specific automated processes, fischertechnik also offers several variations of an integrated factory simulation model. In these factory simulation models, you're essentially going to have four individual workstations. In most cases, it's going to be a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, all designed to work together as one self-contained material cycle. We're, of course, going to look at these models in detail during the course of this presentation. Now, before we get into all that, let me very briefly outline some of the advantages of using fischertechnik solutions. First off, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models are once again designed to realistically replicate, in both appearance and in function, common automated systems, things again such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact, and in most cases you're talking about tabletop size, they're not only ideal for use in the classroom or in office demonstrations, but they're also great for demonstrating software or other technology-based offerings in a trade show environment. The next thing we want to touch on is quality. Each fischertechnik simulation model is a hand-assembled, high-quality German-made product. Each model is available in a 24-volt version for industrial users, and then we also have select models available in a 9-volt version for those not versed in or involved with PLC programming and what have you. Now, in the case of the 24-volt versions, they are designed for use with industry-standard PLCs. Now, it doesn't matter whether you use Allen Bradley controllers, if you use Siemens controllers, or if you use controllers from different manufacturers, whether it be Honeywell, Mitsubishi, General Electric, there's, of course, many others. In any case, you can control these 24-volt models with the PLC that you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming languages from the languages that you see listed on the screen. Now, do note that with the 24-volt versions that we're talking about, in most cases, with one exception, no PLC is included, and all programming and programming guidance, as well as any power sources or other hardware that might need to be attached, are all the responsibility of the end user. Of course, this shouldn't be an issue, as these models are designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming. But as I touched on before, there are also 9-volt versions available of select models. Now, in the case of the 9-volt versions, they ship pre-wired to fischertechnik's own proprietary robotic controllers, which are the robotics TXT, currently the TXT 4.0 controllers. And in the case of these models, these 9-volt models, the controllers are pre-programmed using fischertechnik's own RoboPro graphic programming software. In the case of these 9-volt models, the only additional component required with the 9-volt versions will be the addition of one or more 120-volt power adapters, as I will specify during the presentation for each model. Otherwise, in most cases, these 9-volt models, unlike the 24-volt models, will be essentially ready to use right out of the box. Now, if you're involved in demonstrating or exploring IoT, which of course is the Internet of Things, besides the fact that many end users have adopted some of the models in the primary line of simulation and training solutions for IoT purposes, fischertechnik now also offers a special IoT-focused version of the factory simulation I touched on before. In this case, the factory is designed specifically for exploring and understanding cloud-based control and what is sometimes referred to as Factory 4.0. In this instance, the model is designed to be both controlled and monitored from a special web-based dashboard. And of course, we're going to get into details on this a little bit later in the presentation. Finally, fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options in the marketplace, you'll probably notice that the entry point for many of those products can easily be $30,000 to $40,000 or even much more. Fischertechnik simulation solutions, on the other hand, start off at just a fraction of that price And again, they're also compact, realistic, and high quality in learning and demonstration tools. So with that all being said, let's look at each of the models which are available. We're going to begin with a look at some of the more basic models, and we're going to work our way up to the larger factory models that I talked about, which again consist of several workstations designed to showcase an entire production cycle. So we'll get into that in just a second. We're going to start off with the classic line of fischertechnik simulation models, and the first model in that line is the basic conveyor belt that you see here. This is essentially a transport belt with a length of 275 millimeters that's used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyor belts can easily be connected to increase the length of transport as you may desire. Components on this model will include an excess motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 14 by 10 by 4 inches, and it has a weight of just around 2 pounds. The model is available in both the 24-volt version, which has a multi-pin connector of 26 pins with a 2.54 millimeter grid, as shown here, and again, the 24-volt version of this model, as well as with most of the 24-volt versions we're going to look at this afternoon, will require that you, the end user, have the PLC and the programming to provide for that. But in this case, there is also a 9-volt version, which comes connected to a pre-programmed robotics TXT controller, shown here. In this instance, one 120-volt power adapter is required for operation. Now, I will mention that for this and for all the models that we're going to look at today, the specs are also detailed in the product listings found on the Studica and the fischertechnik.biz websites, as well as in our product brochure, which you can contact us for if you'd like a copy, and I'll provide information on reaching out to us if you'd like to get that. That'll be at the end of the presentation. The next model, the punching machine with conveyor belt, is essentially a variation of the conveyor belt that we just looked at, except of course with this time with a machining station built onto it. Components on this model will include 2 excess motors, 2 push button limit switches, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches, and it has a weight of just about 3.5 pounds. Again, it's available in the 24-volt variation with a 26-pin connector and 2.54 millimeter grid, as shown here, and the 9-volt version wired to the robotics TXT controller, which requires one 120-volt power adapter. The next model we're looking at is the indexed line with 2 machining stations, and essentially what this is it features a U-shaped conveyor line consisting of a milling and a drilling station, along with 4 conveyor belt sections. Other components on this model include 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions are approximately 19 by 18 and by 11 inches. The weight is about 8 pounds. Again, it's available in both the 24-volt version with a 26-pin connector and 2.54 millimeter grid for use with the PLC and the programming of your choice, and a 9-volt version wired to the pre-programmed robotics TXT controllers, in this case 2 of them, and you would use 2 120-volt power adapters with that. Next up is a variation on the idea of a pick-and-place robot, which they call the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for this robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or backwards 90 millimeters, and axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of the model are approximately 19 by 16 by 9 inches, and it has a weight of about 6 pounds. Again, as with the other models we've looked at so far, it's available in a 24-volt version with the 26-pin connector and 2.54 millimeter grid, designed again for the PLC and the programming of your choice, or a 9-volt version wired to a pre-programmed robotics TXT controller, and again requiring one 120-volt power adapter. Next up is the vacuum gripper robot. And in this case, we're going to be able to show you the models in action. Now, as you're going to see here, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, and a solenoid valve. The dimensions for this model are approximately 9 by 19 by 15 inches, and it has a weight of about 7 pounds. The 24-volt version of this model, as well as all of the 24-volt versions that we're going to be looking at moving forward, each have a relay board for motor polarity reversal and both a multi-pin connector, in this case, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, the 24-volt version of this model, as with all of the 24-volt versions, will require you to provide the PLC and the programming. We'll let this play for a second. Yeah, there isn't sound on this part. This is normally where I talk. We're just letting this go for a second here so we can play through. And we're complete there. The next model we're looking at is the automated high bay warehouse. And what you're going to see in this is a model that features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays and 9 individual storage spots. Components on this model include 2 encoder motors, 2 mini motors, 4 push button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each piece. I will mention that this model is a favorite among educators I've spoken with, anybody who's involved with teaching PLC programming. And the reason the teachers like it is because it gives students a lot of very specific coding tasks to address. When you keep in mind all the different storage spots and the precision that has to be used to position the work pieces and the trays in each slot and to retrieve them and what have you. So it gives them a lot of different things to work with, and it's great for that reason. Going back to the model, the dimensions are approximately 19 by 28.5 by 15 inches, and it has a weight of about 18 pounds. Again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, in this case 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. And again, you will need to provide your own PLC and program. In this case, a limited release 9-volt version is also available, which ships pre-wired to a pre-programmed robotics TXT controller, and one 120-volt power adapter is required with that. And I got done way after the video did. We'll do better this time. The next model we're looking at is the multi-processing station with oven simulation. And what you're going to see here is a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of just about 11 pounds. Again, it's available in both a 24-volt version for use with the PLC of your choice, and again, a relay board for motor polarity reversal with both a multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. The 9-volt version in this case is connected to 2 robotics TXT controllers, so 2 120-volt power adapters will be required for all operation. And we'll just let this play out for a minute here. And there we go. So we'll jump right along to the next model in the progression, which is the sorting line with color detection. And the simulation you're going to see here features a system for detecting work pieces of different colors, and it sorts them via conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of just about 10 pounds. Now, as before, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, the end user must provide the PLC and the programming. The 9-volt version again comes pre-wired to a pre-programmed TXT controller, and one 120-volt power adapter is required with that. We'll let this play through. Yep, we are good. Let this go. And there we go. The next model we're looking at is the factory simulation, which combines the last 4 models we've reviewed: the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection, all made into one self-contained material cycle. And the cycle you're going to see works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then moved to the multi-processing station with the oven. After the work piece has been processed by that machine, it's then sorted by color in the sorting line with color detection before being again moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as I've already discussed the components of each model previously, I'm not going to belabor it by restating them here, but what I do want to mention are the dimensions of this model as a whole, as it again combines 4 individual models into one work cycle. It has a much larger footprint. In this case, it's approximately 39 by 31 by 16 inches, and the total weight is between 43 and 46 pounds, depending upon whether you're talking about the 24-volt version or the 9-volt version. Now, due to these dimensions, please note that this model will only be shipped flat as freight, and it's always shipped on a pallet. And I also want to point out that as the factory simulation models do tend to get to be in high demand, especially when we get into the peak ordering season for schools, which is late spring or early summer, please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. A few other things to note. First, this is again available in both the 24-volt version and 9-volt version. In this instance, the 9-volt version is wired to 5 robotics TXT controllers, and because of this, it will require 3 120-volt power adapters because they're daisy-chained. And as with all of the previous models we've discussed so far, the 24-volt version will require the end user to provide the PLC, the programming, and any other hardware required power supplies and what have you. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the 2 factory simulations, which we just reviewed, who may need to transport the model or who want to, of course, protect it when it's not in use. The travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of approximately 53 pounds. But please note that even when using this travel case, these models will still need to be shipped flat on a pallet to protect them from possible damage in transport. So if you're going to be moving this model around, Even inside the travel case, you always want to use a pallet and always want to ship it flat. Moving right along, the next group of models we're going to look at focuses on the area of IoT. Now, these are called the Training Factory Industry 4.0 models. And it's a group of models that are designed to help address how the recent changes in industrial production, which of course were driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before, of course, you apply them and implement them on a larger scale. Now, as the following video does provide a nicely narrated overview of how the factory works, I'm going to step back for a moment and allow you to watch and to listen to the narrator here. So here you go.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node Red. In Node Red, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first-in, first-out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Okay, just provide a little summary of what we've just seen over here. Here are some of the topics which can be addressed with the fischertechnik Training Factory Industry 4.0. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, the connection of upstream and downstream logistics processes, and for experts, the creation of your own unique programming using C++. Now, as you just saw, the model incorporates many features not found in the models that we looked at earlier, perhaps most notably being the use of the cloud-based dashboard for monitoring and controlling the model. And some other examples, of course, would be the camera for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each workpiece, which enables the position of each workpiece in the work cycle to be mapped, and the use of MQTT or message queuing telemetry transport that allows the network TXT controllers to communicate with one another. In regards to the 24-volt version specifically, I should note that it is a bit of a hybrid in that while requiring a PLC for the operation and control of the model, it also incorporates one fischertechnik robotics TXT controller. In this case, the TXT controller serves as the MQTT broker and interface to the fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. Now, in addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. And this allows the option for not only presenting and using data on the dashboard in the fischertechnik cloud, but also being able to display data and calibrate stations of the factory in a Node-RED dashboard. And the model also incorporates newly developed 24-volt adapter boards to interface to the PLC. And this, of course, all ships part of the pre-assembled training factory, and they're connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allow for the speed of the encoder motors to be controlled via PWM or pulse width modulation. And they also have push-pull output stages for phototransistors and for buttons. But unlike the previous 24-volt models that we've discussed, the new 24-volt Training Factory Industry 4.0 includes access to a sample program. And in this case, the program is created in structured text format, and it was created based upon a Siemens S7 1500 PLC, and this is all available for download on GitHub. Now, of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes some small adjustments to the sample program. And to enable that, the source code for all of this is also available for download from GitHub. Now, all of this information and much more is included in the 152-page PDF manual, which can be downloaded from the fischertechnik website. And it's also available from us upon request. So if you want a copy of that, I'm going to provide information at the end of this presentation. You can email us or contact us and get that right away. And I also need to mention that as of last year, there are 2 additional versions of the 24-volt model which are available. And we're going to discuss those 2 options when we provide an overview of the cost of each model in just a bit here. Now, in the case of the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Again, all programming is preloaded on the 9-volt version so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF that comes with this model. Once you've done that, you should be able to get started pretty quickly. The 9-volt version will require the addition of 3 120-volt power adapters, and it should also go without stating whether we're talking about the 9-volt version that we're looking at right now or the 24-volt versions we've been talking about previously. It also is required that the end user, of course, has the ability to access the internet, as well as, of course, you'll need a tablet or another device for accessing the cloud-based dashboard. Now, just to finish things up, the dimensions for these models are approximately 39 by 31 by 16 inches each, with a weight of approximately 51 to 53 pounds, depending on the version. Now, as with the 2 factory simulation models, which we looked at earlier in the presentation, we do recommend the optional travel case to help protect your model during travel or storage. And that's the Training Factory Industry 4.0, which is once again available in both a 24-volt and a 9-volt version. We do have one other model to talk about, and this was just added to the fischertechnik simulation line in late spring of 2023. And this model incorporates the cutting-edge technology that is quickly becoming a part of our daily lives, and of course, that's AI. So this is called the Quality Control with AI System model from fischertechnik, and it's ideal for visualizing this complex subject area in a hands-on manner. And it also creates a sustainable learning experience by linking theory and practice. Processes can be sped up, fault rates and costs minimized, and fault evaluation standardized. The fischertechnik sorting line comes with workpieces in 3 different colors. The three different colors of workpieces have different markings with 3 different processing characteristics, as well as various fault patterns. Just go through some slides here. In each case, the workpieces are scanned by a camera, and they're classified with the aid of the trained AI. Now, depending on the color, the feature, or the fault pattern that's featured on the workpieces are then sorted by the artificial intelligence on the basis of their quality features. The AI used is realized with machine learning in TensorFlow, where an artificial neuronal network was trained with image data. The learned AI is executed on the fischertechnik TXT 4.0 controller. The model sequence control is implemented in the RoboPro coding programming environment and in Python. Now, if you want to go a step further, you do have the option of generating your own AI applications, and the training for this is done in Python, for which a sample program is provided for explanation. And that's the new quality control with AI model. It's ideal for training, simulation, and demonstration, and for education or for research, and of course, for the visualization of AI systems, for learning about machine learning and neural networks, and much more. It's available only in a 9-volt version at this time, but we do hope to have the 24-volt version available for release sometime later in 2024. The 9-volt version here uses the fischertechnik's Robotics TXT 4.0 controller, And as with many of the models we've talked about before, you do require one 120 volt power adapter for operation. So the next big question, just to finish everything up, is how much do these models cost? So we're going to take a quick review of everything that we've looked at before with the pricing for each option. We're going to begin with the conveyor belt. The 24 volt version is $354.95 each, and of course requires the PLC and the programming. The 9 volt version that has the TXT controller is $518.95 per unit. The punching machine with conveyor belt in the 24 volt version, again requiring PLC, is $464.95, and the 9 volt version that comes pre-wired to the TXT controller is $599.95. The indexed line with 2 machining stations in the 24 volt version, which requires the PLC, is $1,199.95. The 9 volt version with the 2 TXT controllers is $1,394.95. The 3D 3-axis robot in the 24 volt version is $1,059.95. The 9 volt version with the TXT controller is $1,369.95. The vacuum gripper robot, only available in a 24 volt version, that is $1,199.95. The automated high bay warehouse in the 24 volt version is $1,448.95. In the 9 volt version, very limited, is $1,318.95. And of course, the 9 volt comes with the TXT controller. The multi-processing station with oven in the 24 volt version is $1,287.95. In the 9 volt version is $1,474.95. The sorting line with color detection in the 24 volt version is $1,126.95. In the 9 volt version, that's $1,128.95, of course, with the TXT controller. The factory simulation. Actually, I made a mistake there because this is only currently available in the 24 volt version. So not a 9 volt version right now. This is $5,195.95. The Training Factory Industry 4.0, this is available in both versions. Whether you're talking about the 24 volt version, which of course requires the PLC, or the 9 volt version with the networked TXT controllers, you're looking at $9,498.95 per. But again, there are 2 new variations you need to know about. First off, there's the Training Factory Industry 4.0 24 volt with the PLC connector board and cabling. So as you see over here, it goes the extra step to include the PLC connection board, the cabling that you'll normally have to do to connect this up to the PLC. This is all included. The cost for this is $12,718.95. And there is also another version which does include the Training Factory Industry 4.0 24 volt with the Siemens S7 1500 PLC. There are 2 versions of this because there's a cost difference depending upon whether you're an educational customer, being a accredited school or academic institution, or if you're a commercial customer, which means not that. Your educational version is $19,319.95. And for commercial customers, you're looking at a cost of $20,124.95 per unit. Again, so the PLC connector, just the board, the cabling is $12,718.95. And with the PLC, you're either looking at $19,319.95 for the educational version or $21,124.95 for the commercial. Other items that I've touched upon, the 120 volt power adapters are very affordable, $12.99 each. And the travel and storage case, which is used for all factory simulation and Training Factory Industry 4.0 models, the ones that I just showed you with the PLCs, the other versions, you're looking at $1,524.95 per case. And the new quality control with AI model, 9 volt version currently is the only one available. That is $2,249.95. And again, we hope to have information on the 24 volt version later this year. So on that note, if you did have any questions, you would be typing them in the Zoom chat window, which I see we're pretty clear here right now. So I'm going to move right along to taking the next step. So if you would like to request a full color brochure and current pricing, if you'd like to ask any questions, if you'd like to request a quote, or if you'd like to speak with your dedicated educational representative, depending on which state you're in, just give us a call. Our toll-free number is 888-561-7521. General questions, quote requests, what have you, you can email us at info@studica.com. But if you do have any questions for me, I know I mentioned things like being able to access the PDF version of the manual for the training factories and other things. If you have any questions about anything I discussed today or anything Fisher Technic related, you can email me directly. And my email is lance.zurich, that's lance.zurek @studica.com. So on that note, I'd like to thank you very much for attending today's presentation. Have a great day. We look forward to hearing from you soon. Take care.